Please put your attendance in the comment window once you join the call. Good morning, all. As we have already started our fifth module and we have discussed a lot of column and strut in this module. We have discussed the fundamentals of column and difference between column and strut. And also we have derived an equation, Euler's equation for solving long column. But we have to solve equations for short column. For that, we need to derive another equation which is known as Rankine formula for columns and strut. This Rankine equation can be used either for long column or short column. There is no problem by using Rankine equation in anywhere. But compared to Euler's equation, it's somewhat difficult. That's why whenever we are doing some calculations with long column, we will normally take Euler's equation that you have already learned as pi square EI divided by LE square. That was the Euler's equation. So now we will go to Rankin's formula. Don't think that by telling it's a difficult equation. No, it's not that much difficult. It's a small equation, but the requirements compared to our normal Euler's equation, little change. So first of all, we will understand what is Rankin formula or Rankin Gordon formula. You have to study both these names. Rankin's formula may be asked in your question paper or sometime Rankin Gordon formula. Don't misunderstand that these two are different equations. These both are same equation named by differently. And the main problem with Euler's equation is the Euler's equation is applicable to long column only for which L by K ratio is larger than a particular value. In the last class, we have discussed what is L by K, that is slenderness ratio. When slenderness ratio is greater than 50 or something, that is a limit is there. It depends on material to material. For a MS, that is mild steel, that will be greater than 70. But when we are taking short columns, we cannot use Euler's formula. As we have Euler's formula, you can just think that formula, that is pi square EI by LE square. If the column length is short, that is LE small, means automatically total crippling load will increase, larger number. That's length will be short and that will affect our calculations of Euler's equation. That's why we are not taking. I will show you the result. And this also taken into account direct compressive stress. When we are studying short column, we have already mentioned that short columns are failed due to crushing load. നമ്മൾ ആദ്യത്തെ ക്ലാസ് പറഞ്ഞിട്ടുണ്ടായിരുന്നു, when we are applying a load, the short column will be crushed, but long column will be bent. There is a difference between short column and long column. The crushing load or direct load is not considered while discussing Euler's formula. That's why we cannot apply this one in short column. And the column of medium length, that is medium column, it doesn't provide accurate results. Euler's equation won't give accurate result for medium column also, because in medium column that will include both crushing and buckling. So if we are not giving importance for medium column, automatically there is a chance of wrong results. And we are providing an Rankine equation, that's an empirical equation. This is not theoretically derived, it's a practically derived one, that is we have this equation by empirical formula. So please note down this one. Heading is Rankine formula. Rankine formula. If you write point by point, that will be easy for you to study. So first point, Euler's formula is applicable to Euler's formula is applicable to Euler's formula is applicable to long columns only. Long columns only. Long columns only. For which L by K ratio, for which L by K ratio, for which L by K ratio is larger than a particular value. 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 Euler's formula. Next point. Euler's formula doesn't take Euler's formula doesn't take the direct compressive stress, doesn't take the direct compressive stress into account. The direct compressive stress into account. The direct compressive stress into account. Direct compressive stress into account. Next point. Thus, for a column of medium length, thus for a column of medium length, thus for a column of medium length, comma, Euler's equation provide, Euler's equation doesn't provide, sorry, Euler's equation doesn't provide, Euler's equation doesn't provide, Euler's equation doesn't provide accurate results. Euler's equation doesn't provide accurate results. Euler's equation doesn't provide accurate results. For solving, next point, for solving short, medium and long column, for solving short comma, medium comma, long column, short comma, medium comma, long column, Rankine forwarded an empirical relation. Rankine forwarded an empirical relation. Rankine forwarded an empirical relation. Rankine forwarded an empirical relation known as Rankine formula. Known as Rankine formula. Known as Rankine formula. Now, just look into the slide. You can see the Rankine formula in the slide. That is 1 by P is equal to 1 by Pc plus 1 by Pe, where Pc is the direct compressive load and Pe is the Euler's load, that is the load, crippling load found out by Euler's method or Euler's formula, that is taken as PE. Here you can see that the same equation in different textbooks are denoted as different types. That is, normally we are taking 1 by P is equal to 1 by PC plus 1 by PCR, where 1 by PC is the crushing load or the direct load on the strut or column, and PCR or PE, that is the change. PCR and PE are same. That is known as Euler's equation load, that is crippling load. We have already discussed what is crippling load or critical load or buckling load, that is PCR or PE. I will take PCR as common for solving this equation, and we have to know what are the equation for direct stress. For direct compressive stress, we know direct compressive load, we have an equation, that is direct compressive stress into area. We know that load is stress into area, that is sigma C into A. You can see the relation. Normally for a material, this value will be constant. That is compressive strength is known to us and area won't change for a material. So PC will be sigma C into A, and PCR or PE, that is crippling load, having the equation as we have already derived this Euler's formula, that is pi square EI divided by LE square, not L square, LE square, that is effective length square. And you need to substitute this value. If for a long column, the material will be very long, that is effective length will be very large. If effective length is very large, then PE will become very small. Okay, when L is very large, PE will become very small, and 1 by PE, that is 1 by PCR, will become very large. Understood? LE വലുതാവുന്ന സമയത്ത് ഓട്ടോമാറ്റിക്കലി പി സി ആർ എന്ന് പറയുന്നത് ചെറുതായിരിക്കും. പി സി ആർ ചെറുതാവുക എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ 1 by PCR എന്ന് പറയുന്നത് വളരെ വളരെ വലിയൊരു വാല്യൂ ആയി മാറും. ഓക്കെ, so when we are considering that this value 1 by PCR will be very much bigger than 1 by PC, that is written in the case of 2, that is for long column PE or PCR is very small, therefore 1 by P, therefore 1 by PCR is quite large in comparison to 1 by PC. Thus crippling load P practically equal to PCR. No need of 1 by PC. That is for a long column, 1 by P will be equal to 1 by PCR. This equation is similar to our Euler's equation, or PCR is Euler's formula, and P can be written as P is equal to PCR directly. I think you can understand this thing. For the short column, L will be very small. You can see that L will be very small. That's why when we are solving this equation, PCR will become very large value. PCR will become very large value. Automatically 1 by PCR will become a very very minute or negligible value. So that's why for a short column, PCR or PE is very large, and therefore 1 by PCR or PE is very small compared to 1 by PC. Thus crippling load is practically equal to PC, that is Rankine load. It can be written as Rankine crippling load, or P is equal to PC. For a long column, P is equal to PCR. For a short column, P is equal to PC. If you have any doubt, you can ask me now, or otherwise you can write these equations. That is, in the last slide we have written that Rankine forwarded an empirical relation. After that you have to write the relation. Better write the second relation. No need of writing the first relation. This will be followed in upcoming slides. So you have to write 1 by P is equal to 1 by PC plus 1 by PCR. 1 by P is equal to 1 by PC plus 1 by PCR, where, please write down in your notebook, where P is the Rankine crippling load, where P is the Rankine's crippling load, where P is the Rankine's crippling load, Rankine's crippling load. PC is the direct compressive load. Don't write that ultimate load, that's similar one. So you can write direct compressive load. PC is the direct compressive load, equal to sigma C into A, equal to sigma C into A, equal to sigma C into A, equal to sigma C into A. Now PCR equal to Euler's crippling load. PCR equal to Euler's crippling load. PCR equal to Euler's crippling load. Euler's crippling load equal to, and the equation, pi square EI divided by LE square. Don't write L square, that is LE square. LE square. LE square. Effective length. Pi square EI divided by LE square. We have to mention two conditions. The note. Write a note. For a short column, first point ആണ്, for a short column, effective length LE will be very small. For a short column, effective length LE will be very small. So PCR become very large. So PCR will become very large. PCR will become very large, and 1 by PCR will become very small, and 1 by PCR will become very small compared to 1 by PC. 1 by PCR is very small compared to 1 by PC. Thus Rankine's crippling load, P is practically equal to PC. P is practically equal to PC. That is മനസ്സിലാക്കേണ്ട കാര്യം, there will not be any effect of PCR for a short column. So next condition, the second condition, for a long column, for a long column, effective length will be very high. Effective length will be very large. 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 And PCR will become very small. PCR will become very small, and therefore 1 by PCR, and therefore 1 by PCR is quite large, is quite large, is quite large compared to, is quite large compared to 1 by PC. 1 by PCR is quite large to 1 by PC. Thus, Rankine crippling load P, thus Rankine crippling load P is practically equal to, is practically equal to PCR, practically equal to PCR, practically equal to PCR. This is an important equation. You have to note this equation because after solving, or after we have to substitute all values of PC and PE in this equation, and we will get an ultimate equation or final equation for Rankin formula, and we need to substitute this equation, or we need to do Euler's equation as well as Rankin equation for solving the other equations. So very important one. So first of all, we need to derive equation. For that, we know that 1 by P is equal to 1 by PC plus 1 by PCR. That can be written as, when we are multiplying or cross multiplying everything or adding these both terms, we will get PCR plus PC divided by PC into PCR. I think you know that 1 by PC plus 1 by PCR is equal to PCR plus PC divided by PC into PCR. It's a common equation. No need of worrying anything. So 1 by P is known to us. When we are substituting as P, that is, we have to take the opposite side top. That is, you will get P is equal to PC into PCR divided by PCR plus PC. That is reciprocal of this term. That will be P. P is equal to PC into PCR divided by PCR plus PC. So now we will divide all these terms, that is top terms and as well as bottom terms with PCR. Dividing all terms with respect to PCR, then top term will become PC. Here that will become 1, and here that will become PC by PCR. That is, the equation will become like this. That is PC divided by 1 plus PC divided by PCR. And when we are substituting the values, we know that PC is equal to sigma C into A. In the last slide, we have shown that, or you have written in your notebook, just take that thing. That is PC equal to sigma C into A, as well as PCR is Euler's formula, that is pi square EI divided by LE square. When we are substituting both the terms, we will get PC as sigma C into A divided by 1 plus PC into A divided by pi square EI divided by L square. Okay, please write down till now. നിങ്ങൾ എഴുതി കഴിഞ്ഞിട്ടാകുമ്പോൾ ഞാൻ അടുത്ത സ്ലൈഡിലേക്ക് പോവാം. ജസ്റ്റ് സബ്സ്റ്റിറ്റ്യൂഷൻ മാത്രമേ ഉള്ളൂ, വലിയ ബുദ്ധിമുട്ടില്ല. നെക്സ്റ്റ് സ്റ്റേജിൽ ജസ്റ്റ് എല് മുകളിലേക്ക് എടുക്കുക, എൽ സ്ക്വയർ മുകളിലോട്ടേക്ക് പോകും. ദാറ്റ് ഈസ് സിഗ്മ എ ഇൻറ്റു എൽ സ്ക്വയർ എന്നുള്ള ടേമിലേക്ക് വരും, ഈ താഴെയുള്ള ഈ പ്ലസിന് ശേഷമുള്ള ഈ ടേം. So please write down till now. It's a very simple derivation. If you know the empirical relation, that is 1 by P is equal to 1 by PC plus 1 by PCR, then it is very simple to solve this equation. Very small derivation. If you study well, all can score good marks for this particular subject. Have you written this one completed? Please do it fastly. First of all, we have given the equation for 1 by P, that is Rankine coupling load, that is 1 by Pc plus 1 by Pcr. After that, when we are adding these terms, we will get Pcr into Pc divided by Pc into Pcr. And when we are dividing all terms with respect to Pcr, we will get Pc divided by 1 plus Pc by Pcr. And substituting the values of Pc as well as Pcr in the equation, we will get equation as such. May I go to next slide? No one is responding. Can anyone
Yes,
respond?
sir.
Hello?
Yes, sir.
Yes, sir.
Okay, hope you have completed that one. I'm going to the next slide. Am I audible?
Yes, sir.
Okay, okay. Okay. Now we will take L square at the bottom. That is L E square actually. That is commonly taken as L. That is we are taking towards upward. When we are writing capital letter L, it will be effective length. Actually, here that is mandatory that we have already discussed and put LE. So if you put like this, we can use the same equation for all the end conditions. That is effective length. You know that both sides are hinged or both sides are fixed, or one end is fixed and other end is free, or one end is fixed and other end is hinged. In all equation commonly we can use the same relation. So we have equation that sigma c into a divided by 1 plus sigma c into a square into le square divided by pi square ei.
അങ്ങനെ എ
After
സ്ക്വയർ വന്ന്
substituting this value, hello,
എ സ്ക്വയർ എങ്ങനെയാ വന്ന് ഡിനോമിനേറ്റർ
1 minute. That's only a. Actually, not a square, that is a.
ഓക്കെ
Sorry. There is no a square. That's textbook mistake. That is a. Sigma c into a into L square divided by pi square ei. ആരെങ്കിലും എ സ്ക്വയർ എന്ന് എഴുതിയിട്ടുണ്ടെങ്കിൽ ഒന്ന് മാറ്റണേ. സ്ക്വയർ ഇല്ല ആക്ച്വലി അവിടെ. After that, we need to substitute the value of I, as we know that I is equal to AK square, right? Area into K square will be I. Common equation for moment of inertia. When we are substituting I as A into K square, we will get the equation as sigma C into A 1 plus sigma C into A into L square. Here that is corrected actually. There is no square that mistakenly added. S into L square divided by pi square E into I is substituted as A into K square. After that, you can cancel A in both top and bottom side. So you will get the equation as sigma C into A divided by 1 plus sigma C divided by pi square E into L by K square. This is an important equation. This is an important equation. And finally, the Rankine formula will be sigma C into A divided by 1 plus alpha into L by K square. In some cases, instead of alpha, they will put A. Both alpha and A are Rankine constant. This alpha is known as Rankine constant, and you can see that the value of Rankine constant will be sigma c divided by pi square e. This term is replaced by a common term, that is alpha, because sigma is constant, pi square is constant, and E is constant for a material. For such thing, we will take this whole term as Rankine constant known as alpha. Please note down. Please note down from top to bottom. Have you completed? First, you need to take L towards top side. After that, you need to substitute the value of I, and after that you need to cancel a in the top as well as bottom, that is area of cross section is available in both top and bottom, so that get cancelled, and after that you will get an equation, and sigma c by pi square e can be taken as a common term known as alpha or Rankine constant. That in almost all questions, if you are asked to solve this problem, they will directly give Rankine's constant. So directly you have to substitute the value here and solve the equation. So your non alpha, and the final equation will be P is equal to, you need to write here P and make it X in a box. Here the term will be P, and you need to make a box. It's an important equation. This is known as Rankine formula. This is known as Rankine formula. May I go to next slide?
Yes, sir.
Okay. We need to get some important two values of Rankine constant for MS as well as for cast iron. Commonly, these both will be asked in your question paper. So just remember these two values. If not even given in your question paper, you need to take as such. That is, for a mild steel column with both and hinged, alpha will be 1 by 7500, and for cast iron column with both and hinge, that can be 1 by 1600. This is an important term. This is an important term. Now you need to write the Rankine common formula. That's not no variation, as we have derived equation as effective length. The same equation will be this one. So you need to remember what is LE for both and hinged or pinned. Both and hinged means LE will become L. If both and fixed means LE will become L by 2, and one end fixed and other end if E means LE will become 2 into L. And finally, if one end fixed and other end is hinged, in such case LE is equal to L by root 2. These are the four conditions, and whenever we are solving a problem, we need to check what is given in the problem. According to that, we need to derive this equation. So write the top one, that is for mild steel column. For mild steel column with both and hinged, with both and hinged, comma, Rankine constant alpha is equal to, Rankine's constant alpha is equal to, Rankine's constant alpha is equal to 1 by 7500. Alpha equal to 1 by 7500. That is 7500. 1 divided by 7500. Next line, for a cast iron column with both and hinge. Next line, for a cast iron column with both and hinged, comma, Rankine constant alpha is equal to Rankine's constant alpha is equal to 1 by 1600. 1600. 1 by 1600. No need of writing another equation because in the previous case we have used the same equation. So whenever we are doing a problem, we need to consider the end conditions. That's enough for today's class. Thank you for listening to me. And next class we have to do some problems regarding Rankin's formula and compare it with Euler's formula, as we have already know how to solve Euler's formula. So now you need to compare the results of Rankine formula as well as Euler's formula. It's very important thing. Please put your attendance in the command window if anyone pending. Please put your attendance in the command window if anyone pending. Absolutely, sir. 3, 9, 14 and 15. Adarsh Preman, Hridik, Muhammad Sain Ashraf, Nihal Abdul Nazir.